Alright, in this video we want to learn about a new set of identities, and those are called the sum and difference identities. Sum refers to addition, obviously, and difference refers to subtraction. And they're listed right here in this table, the sum and difference identities. These symbols, by the way, that's the symbol alpha and that's the symbol beta. But if that's confusing to you, you can just replace those with A and B or X and Y. Those are just Greek letters. Typically, Greek letters are used in trig. So all that this means is that the sine of any angle, okay, so for example, if you had the sine, let's say, of something like this, 10 degrees plus 20 degrees, okay, and we already know sine, that's 30, sine of 30 is 1/2. This says the following, and there's a proof for this that's a little bit beyond the scope of this course, but this says that if you expand that out, your first value in this case is, for this one, it's 10. That would expand out to be sine of, there's our first value, 10, cosine, and then I'll use a different color here, our second value, so in this case our second value is 20, cosine of 20, plus, okay, and then this plus or minus right here means if it's plus here, it's going to be plus here. If it's minus there, it's going to be minus there. Okay, the only one that works opposite is tangent. Right here the plus is on the top, but if it's tangent of things being added, then down there it would be a minus. Okay, and then plus the cosine of, once again, cosine, this first angle, alpha angle. So in our case, alpha, let me label it, alpha is 10. Okay, and then times the sine of our second angle, our beta angle. So in this case, beta is right there. So you'd have the sine of 20. What this basically says is the sine of 10 plus 20 is equal to this whole thing if you were to solve that out. So this will be clear when we do some examples, but really all you need to know in order to do these, at least for most of these problems, they're going to ask you things involving one of these three angles, 30, 45, or 60. And an easy way to remember this table, I always tell people, is to do it as follows. Everything in this table for sine and cosine is going to be square root of something over 2. And the sines count up, so the sines go 1, 2, 3, and the cosines count down 3, 2, 1. Tangent is sine over cosine, so 45 would be root 2 over 2 sine over root 2 over 2 over cosine. That just equals 1. Anything over itself equals 1. And if you divide these other ones, you get root 3 over 3 is the tan of 30, and root 3 is the tan of 60. So here's our strategy. We have to take the angle they're giving us, so in this case they're giving us 255, and we have to make it either into the sum or into the difference of two other angles, and one of those other two angles should be one of the three angles in our table right here. So either 30, 45, or 60. Then we just pick the formula to plug into, and we use it says ASTC. Okay, so ASTC means all students take calculus. So we know for a fact when we're looking at 255, we know that it has to be the sum of two other angles. Okay, let me clear off this stuff right here. We know we're going to be using the sine formula, so let's just write that down, and then we will figure out how to fill it in as needed. So the sine of two angles being added together, I'll use A and B instead of alpha. Let's first figure out what we're adding. So 255, it ends in 5. Anytime an angle ends in 5, I know that 45 is going to be involved in it somehow. 255 equals 45 plus what? And you just have to do 255 minus 45. That turns out to be 210. So this is the same thing as the sine of 210 plus 45. It does not matter what order you write those in. So you could have written it as 45 plus 210. Let's call this our A angle, and let's call this our B angle. So here's our formula. We're doing a sum right here, so I'm going to use the plus part of this. So sine of A plus B equals sine A cosine B plus cosine A sine B. Now all we have to do is simply plug this stuff in. So we'll kind of do it color-coded here so you can see it a little bit easier. Okay, the key step here is just figuring out what formula we're supposed to be using, and then once we have that formula, we plug stuff in. So our A is 210. So wherever there's an A in this formula, I'm going to put 210. So 210 goes here, here, and here. And then wherever we see a B, B is equal to 45. So plus 45, cosine 45, sine 45. Okay, now all we have to do is just go down the line, simplifying these. So we already know cos 45 and sine 45. Those are right here in our table. So we'll replace each of these as we go along. So the cosine of 45 and the sine of 45 are both root 2 over 2. So let's add those together. or rather multiply them together, I should say. So root 2 over 2 goes here, and root 2 over 2 also goes here. And then we are adding that to, or we're multiplying those together with the sine and the cosine of 210. So sine of 210, cosine of 210, again, it has to be one of these angles that's up here in our table, either 30, 45, or 60, because those are the only ones we have exact values for, and they're asking us in these problems to find an exact value. So if we look at 30, 60, and also 45, let's use a unit circle. 210 degrees, let's trace that angle. So this would be 90. That's 180. 210 puts us about right here. That's a 210 degree angle. And what we have to do is find the reference angle. Okay, the reference angle is this this one in yellow right here. I don't know if actually let me make it green so you can see it better. This one in green is the angle that takes us to the closest x-axis, which is at 180. So 210 minus 180 gives us 30 degrees. So that means the sine of 210 and the cosine of 210 are exactly like the sine and the cosine of 30, with one exception, and this is our last step. It says plug into the correct formula, simplify using this table and this, and using ASTC. So all we have to do for that is we have to figure out if we are in the third quadrant, which is where 210 puts us. In this third quadrant, it looks like T meaning tangent. ASTC stands for all students take calculus. Only tangent is positive, so sine of 210 is like sine of 30 except the negative of that. And cosine of 210 is like cosine of 30, except because we're at 210, because we're in the third quadrant, that's going to be negative. So that means the sine of 30, let's look up at the table again, and it's always a good idea to have this table in front of us. The sine of 30 is 1/2, square root of 1 is just 1, so the sine of 30 is 1/2, but I have to make it negative because I'm in the third quadrant. Cosine of 30 is root 3 over 2, but I have to make it negative again because I'm at 210, I'm in the third quadrant. Now our last step is to simply multiply these out. So how do we multiply fractions? We just multiply the top. Negative 1 times root 2 is negative root 2. 2 times 2 is 4. And then over here, negative root 3 times negative root 2 would be negative root 6. That's coming from this times this. And on the bottom, 2 times 2 equals 4. And now we can just combine these and get negative root 2 plus negative root 6 over 4. Okay, that's our exact answer. Here's a good and easy way to check. Okay, we come to the calculator and we started with sine 255. So let's plug in 255. This is not going to give us an exact answer. It's going to give us a decimal. You can see negative 0.96. Actually, let's make sure we're in degrees, which we are. Okay, I hit mode there to get to degrees. So negative 0.6. Now let's plug in our other answer. So our other answer, I'm going to put a parentheses, was negative radical 2. Okay, and then plus negative radical 6. And if we do this correctly, we should get that exact same answer. This is an easy way to check that we did it correctly. Most of these problems will ask you to give an exact value though, and that's not given by the calculator. Okay, and you can see we do get the same answer, so that's an easy way to check. Alright, so now let's try this second one right here. This is the tangent formula. I want to show you an example of sine and cosine are basically the same. Tangent is kind of the formula that's a little bit different. So tangent of I always find it easier to work in degrees. So let's change negative 5 pi over 12 into degrees. We can do that by multiplying by, there's 180 degrees in every pi radians. Okay, the pi's will cancel. 12 goes into itself once. It goes into that 15 times. So negative 5 times 15 equals negative 75 degrees. And let's figure out where that puts us. Negative 75, here's 0. Negative means we're going counterclockwise. We're going this way. So this would be negative 90. We don't want to go quite that far. Here's negative 75 right here. So the question is, what is that as a positive angle? It would be this purple angle right here, which is almost all the way around, almost 360, minus that 75. And that's going to give us 285 degrees. So this is really asking us for the tangent of 285 degrees. Okay, now see if you could pause the video and try to figure out what to do next. Okay, it's the same as the other problem. We need to make this into a sum or a difference, and you know obviously you can write a difference as a sum instead of minus something. You can write it as plus negative. It's ending in 5, so anytime something ends in 5, I know it has to involve one of these three angles, and if it ends in 5, I know that 45 has to be part of it. So 285 is the same as 45 plus 240 degrees. Okay, here's our formula right here, and it's the sum formula. It's this top one. Okay, so let's use different colors here. We'll say the 45 is going to be our A angle, and we'll say the 240 is going to be our B angle. So let's expand this out. So tangent of 45, it's going to be plus, and then just kind of fill in the skeleton outline of this. Okay. One thing I want to point out, if you notice on the bottom of this right here, hopefully you can see right here the minus and plus is upside down. That means if you're using tangent of plus, the bottom one has to be a minus. If you're using tangent of two angles minus, the bottom one would have to be a plus. So we're going to use minus because that's how they structure that formula right there. It's basically the opposite of what you're doing. If you're adding, then the bottom is minus the top. It's basically whatever's on top is what's going to determine. All right, so we have our A is 45 degrees, so I'm going to put 45 wherever I see an A right here. So there's 45, there's 45, and then I'm going to put a B wherever I see a B in that formula, or a beta. That's the Greek letter for B. 45 and 45, or 240 I should say. So now what we need to do is just solve it using this table and using all students take calculus. So the table is, where is it? Well, I erased it, but we'll redraw it as needed. So the tangent of, here's the column for tangent, okay, 30, and then 45, and then 60. So the tangent of 30 is root 3 over 3. This is 1, this is root 3. So let's expand this out. So the tangent of 45 is just equal to, this right here is equal to positive 1. Tangent of 240, okay, well, let's make the unit circle. 240 puts us, there's 90, there's 180. 240 is about right here. So we, as always, when we're finding angles outside of the first quadrant, we need to find the reference angle, which is this angle that takes us back to 180. And that would be 60 degrees because 240 minus 180 is that right there. It's 60. The only catch is that we are in the third quadrant where tangent is positive to begin with. So we can change this into tan 60, and it's positive tan 60 because that's how, oh, actually, you know what? There's a mistake in this formula. I'm sorry. It's supposed to be tangent of 240. So this down here should be tan 240. Let me erase it so it's clear. So we have to use all students take calculus to tell what quadrant we're in. We're in the third quadrant anyway, so it doesn't affect us in this case. So tan 240. All right, so tan of 60, well, we have our table right here. Tan of 60 is radical 3. So we can change this right here into radical 3. So the top is going to become 1 plus radical 3. And the bottom is going to be, let's simplify this, tan 45, we already said that's 1. Tan 240, we just figured that out as radical 3. 1 times radical 3 is radical 3, but then we have this 1 minus part, so 1 minus radical 3. Okay, this is the right answer. There's only one catch, and that is we normally don't like to have radicals in the bottom. So we can get rid of that by doing something that you probably learned in algebra, and that's called multiplying by the conjugate of the denominator. So the conjugate of 1 minus root 3 is 1 plus root 3. That's the conjugate of this thing. And then whatever I do on the bottom, I have to do on the top, because if I'm multiplying, if it's 1 plus root 3 over itself, this whole thing right here is the same as multiplying by 1. And when you multiply something by 1, ask yourself what happens in that case. And the answer is nothing happens. It stays the exact same. So let's simplify this out. So we'll FOIL the top and we'll FOIL the bottom. Let's do the bottom first. It's a little bit easier. So if we FOIL the bottom, we have 1 times 1, which is 1. Then we have 1 times radical root 3 plus root 3. Negative radical 3 times 1 is minus radical 3. And so those are going to cancel, and that's what we wanted to happen. And then we have negative radical 3 times positive radical 3. A negative times a positive is a negative. Radical 3 times radical 3 is just 3. It's radical 9, which is 3. So on the bottom we have 1 minus 3, that's negative 2. All right, then we have the top. So the top is 1 plus 1, which is 1. 1 times root 3 is radical 3. Root 3 times 1 is another radical 3. And root 3 times root 3 is again 3. So we have 1 plus 3, which is 4. And we have 1 radical 3 plus another radical 3 is 2 radical 3. Then all we need to do to simplify this at the very end is everything here can be divided by 2, or by negative 2 really. So that divided by negative 2 is 1. That divided by negative 2 is negative 2. That divided by 2 divided by negative 2 is negative 1. And that radical 3 stays along for the ride. So our final answer is negative 2 should be minus, and we don't really need to write the 1 there, minus radical 3. And then as always, you could put this in a calculator, and you could put, I believe that comes out to be negative 3.732. And then if you put tan of the original, which was tan of negative 5 pi over 12, let's check that to be sure it's negative 3.732 as well. So we will check this in the calculator. We started out in radians, so I want to change this into radians just to make sure we are consistent here. So now we're in radians, and we're going to do tan of what we originally started with, which was negative 5 pi over 12. So negative 5 times pi divided by 12, and if we do this correctly, it should be negative 3.73 because that is what we got using the exact value, and it is negative 3.73.